Hello everyone and welcome back to our channel Quaint Cosmos. When light moves, it does not just move forward. Yes, light doesn't just move forward. It can spin, twist, swirl like a microscopic tornado. And when light does so, means when light twists, spins or swirls, in that case what happens? In that case, the light does not hold only two states. In case of qubits, a qubit holds only two states, either 0 or 1, or the combination of the two. That superposition concept. So in case of qubit, that thing happens. But here, when you are using the special property of light, okay, means when light actually can twist, spin or swirl, in that case you are going to use that property of light to hold information or to represent states or quantum levels. In that case, that particular property does not hold only two states. That can hold two states, but actually that is capable of holding more than two states. And there is no upper limit. So it can be 3, 4, 5, dozens, hundreds, thousands. Okay, there is no upper limit. And that is called actually twisted photon. If photons have this property, that is called twisted photons. And these are naturally found. These are universe's natural qudits. Qudits, this concept you know. Classical computers, we are not talking about classical computers here. We are talking about only quantum computers. So in case of quantum computers, the concept of qubit, this is known to you. In case of qubit, one qubit, that means a qubit, that is what actually? It is a quantum particle. And only two states are there. Two states are used, either 0 or 1. On or off. And what is the advantage of using this concept? Because superposition, they exist in superposition. So this concept is used in case of qubits. But since we are talking about qudits, where number of states, there is no upper limit for number of states. Therefore, there is one advantage. What is the advantage? Just consider the qubit you are talking about, that ranges from -5 to +5. So how many numbers are there? -5 to +5, that means -5, -4, -3, that way. The midpoint is 0, then again +5. That means 11 states. So these are what actually? -5 to +5 or -50 to +50 or -10 to +10. These are what? These are actually topological charges denoted by L. Denoted by L, topological charge. And these are related to what? These are related to that orbital angular momentum. Spin angular momentum of light or photons? That is known to you, that was discovered in the year 1930. And this is orbital angular momentum, or in short, this is called OAM. This was discovered just 27 years ago. In the year not 27, actually 33 years ago. In the year 1992. In the year 1992, this was discovered, this special property known as orbital angular momentum of light. And when light is actually spiral shaped, means when the light is shaped like a spiral, in that case, its wavefront is not like a flat surface. Okay, its wavefront, the wavefront of the light is not like a flat surface. Then in that case, it becomes like the shape becomes helical actually, just like a corkscrew moving through space. And this twist, this twist is actually not a decoration. This is what then? This is actually the information, quantum information. Okay, now so I was talking about what? This is denoted by D. This number of twists per photon or per particle. This is known as topological surge and denoted by topological, not surge, it is charge, topological charge, okay, denoted by denoted by L, and it varies from, say for example, -5 to +5. So number of states involved here is 11. Okay, number of states involved here is 11. Now you compare between qubits and qudits. So if you use 7 qubits, then in that case, what is the total number of states? If you use 7 qubits, it is equal to 2 to the power 7, which is equal to 128. So say for example, we are talking about 100 states. Our target is to create 100 states. So if you use 6 qubit, what is the number of states in that case? 2 to the power 6, which is equal to 64. So this is less than 164. So that means what? You have to increase one more qubit. 6 was there, result was 64. Now 7, so result is 128. So if your target is 100 states, creating 100 states, in that case you need to use 7 qubits. But now think about that qudit. We are now talking about only photon. So suppose the photon where this twist varies from, or that topological charge varies from -5 to +5. So number of states is how much? It's 11. And if it is -50 to +50, then it is 101. -50 to +50, then it is 101. That means the job which is done by 7 qubits, the same job can be done with only one photon particle if that photon particle has 100 states. And that is possible because there is no upper limit. That is possible because there is no upper limit. You can use that much. And that is not the limit. Okay, just for example, we are talking about like this. So it depends on that topological charge actually. But limitlessly you can create that thing. And accordingly you can use. So what is the advantage of using qudits? What is the advantage? Number of particles you can reduce. Number of particles in your system you can reduce if you use qudits instead of qubits in your quantum system. Okay, we are talking about only quantum computers. In your quantum computing system, if you replace qubits with qudits, this much advantage you will get. Now for many tasks, many calculations are there in case of computational physics. Okay. In case of computational physics or computational chemistry, cryptography, millions of qubits are required. So drastically that number can be reduced if those systems use qudits. Drastically that number can be reduced because if you involve more qubits in your system, then more noise is there, more error is there, more error correction is required. For the systems having much more number of qubits. But if you use qudits, number is drastically reduced. Number of particles, okay, quantum particles is drastically reduced. So automatically noise is reduced. Need for error correction is reduced. Anyway, this is the main concept we are talking about here. Okay, the main concept of orbital angular momentum. The same particle photon that is being used as a qubit in many systems. And that same photon particle can be used as a qudit. Okay. This is really amazing. The same photon particle is being used as qubit in many systems, in many quantum computing systems, and we are talking about the same photon particle which can be used as qudit to get much more advantage. But what the property there means, what the property which is being used in a qubit system, they are dealing with actually that spin of photon. Means spin angular momentum actually. You know, if you have studied polarization of light, then you have the concept, the concept of spin angular momentum. So actually spin of the particle, the spin of photon is used in case of qubits. And spin, it is denoted by only two values, two states, 0 and 1. But this OAM, that is orbital angular momentum, this is not limited to 2. There is actually no upper limit, and this is the advantage, and already researchers are working to build such things, means quantum computers using qubits and using this photon particle. Photon particles are not only the qubits. So many quantum particles are there which can be used as qubits. But here in our today's video, we are talking about only photon particles and that special property. Using that property, we can use photon as qubits. And in the year 2024 and 2025, this is 25 actually. Okay, they demonstrated actually this logic. Okay, using light vortices. So, and many more points are there to be discussed under this title, twisted photons, but those things will be discussed in separate videos. Okay, this is actually a huge topic. In a single video, covering all the aspects of this twisted photons is not possible. And if it is done, then most of the audience won't watch at all. Anyway, so I was talking about the main property, and the most interesting thing, most amazing thing is here that the same photon particle is used as qubits in many systems, already being used, and we are talking about the same photon particle to be used as qubits. Yes, qubits. Okay, same photon particle, qubits, but different property of what? Different property of photon particle is being used here. This property is here OAM, optical, not optical, orbital. Orbital angular momentum. And if you think about how to visualize this thing, you can visualize spiral staircase. You have seen metallic steel structure, spiral staircase. Each step can be considered as a quantum level. And the number of steps in a spiral staircase, that is unlimited. According to your wish, according to your requirement, you can increase the number of steps. So in case of qubit, there are only 2 steps in that spiral staircase. There are only 2 steps. And if you talk about that qubit, if you want to visualize this qubit of photon, then number of steps or the number of quantum level is unlimited actually, is limitless. So instead of considering a laser beam as just a cylindrical, right-angled cylinder, okay? You do not think that way. Instead of thinking a laser beam as a cylinder, you just think this way, that a laser beam is like a spiral staircase. Anyway, so many things are there in a single topic. Twisted photons, and this is not possible for me to discuss all the aspects. Okay, main concept was what? Number of states available using a special property, that OM property. It is limitless, and that's why scientists have become able to use this special property to build new generations, or yes, better to say new generation, quantum computers, new generation of quantum computers. Okay, and the target is what? Why they are doing this thing? Because to make the systems noise free. Okay, and requirement is actually for the solution of practical problems. So many practical problems are there, like quantum AI, quantum cryptography, then computational physics, computational chemistry. So many problems are there where actually practically millions of qubits are required, and scaling those things up is not possible right now. And one more advantage of using this natural qubit photon is that ultra cold labs are not required. Okay, ultra cold environment is not required. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video interesting, so please like, share and subscribe. Anyway, I want to say one more thing, that depending on the same thing, means main topic of discussion is what? Twisted photons. On these twisted photons, I'll make many more videos. Okay. Anyway, so this was all about today's topic, and this is the end, and thanks for watching.